What's up, you freaking geniuses? So in this video, I'm going to teach you how to graph rational functions. So I'm going to teach you how to find everything: the asymptotes, the x and y intercepts, the holes, if there are any, and the domain and range, right? So I have the rules on how to find each of those things up here. Don't worry about those right now. Let's just get into our first example, and then we can see how we use each one. So here, first, we have f of x is equal to 3 over x minus 2. So first of all, let's find the x-intercepts of this rational function. In order to do that, all you have to do is set the top, the numerator, equal to 0 and solve for your x terms. So here, in this numerator, we don't have any x terms, okay? So there's nothing to solve for. So since we don't have any x terms, that means there are no x-intercepts, all right? So for our x-intercepts, we'll simply say that we have none, all right? Now, let's go on to finding the y-intercepts. And in order to find the y-intercepts, you simply set your x terms equal to 0 and then solve for y, or in other words, f of x, okay? So for our y-intercepts, let's just write it over here. We're going to get that f of x is equal to 3 over, and then we have an x term right here, so we'll plug in a 0 right there. So we're going to say 0 minus 2. So this is going to be equal to 3 over negative 2, or in other words, negative 3/2. Or if you wanted to write this as a decimal, that'd be the same thing as negative 1.5. Okay, so as you can see, we have a y-intercept, or in other words, we're going to hit the y-axis at negative 1.5. Now let's move on to finding the horizontal and vertical asymptotes. So in order to find the horizontal asymptote, you're going to run into 3 different cases. And all you have to do is compare the biggest exponent in the numerator with the biggest exponent in the denominator. Okay, and this is specifically related to your x terms. So if the biggest exponent on top is smaller than the biggest exponent on the bottom, then you have a horizontal asymptote at y is equal to 0, or in other words, the x-axis. If those two exponents are equal to each other, then our horizontal asymptote is at the ratio of the coefficients. And if the top exponent is bigger than the exponent on the bottom, then we don't have a horizontal asymptote. Okay, so for this function, you can see we don't have any x terms on the top, but we do have an x term on the bottom, right? This x basically to the first power. So since we don't have anything on the top and all we have is something on the bottom, then the bottom one automatically wins, all right? So this would be an example of case number 1 right there, right? Because the bottom exponent is bigger than the top exponent because, well, the top doesn't have any exponents. Okay, so then that means we have a horizontal asymptote right here at y is equal to 0. Now, in order to find, lastly, the vertical asymptote, we just need to set the denominator equal to 0. Okay, so for the vertical asymptote, the denominator is x minus 2, so we'll simply set that equal to 0. So solving for x here, we can add 2 to both sides, those cancel out, and we get that x is equal to positive 2. Okay, great. So now that we found our intercepts and our asymptotes, let's graph these. So first of all, we don't have any x-intercepts, so we're not going to touch the x-axis at all. However, we do have a y-intercept at negative 1.5. Negative 1.5, we'll say, is about there, all right? Now we have a horizontal asymptote at y is equal to 0. So this is the y-axis, and 0 is right here. So we have a horizontal asymptote right here at y is equal to 0. And then our vertical asymptote is at x is equal to positive 2. So here's our x-axis. This is positive 2. So that means we have a vertical asymptote right here at positive 2. Okay, great. So as you can see, when you draw your asymptotes, we kind of break this up into quadrants, right? So it's like this is one quadrant right there. Here's another quadrant 2. Here's 3. And here's 4. So here we have an intercept. So we know part of our function is going to run through this point. So we know that part of our function is going to be in this quadrant down here. So we're going to have a function that looks something like that, right? We get really close to the asymptotes, right? And now we need to figure out what happens on this side of the graph. Are we going to have something like that? Or are we going to have something like that? Well, in order to figure that out, we simply need to test a point over here on this side, and specifically an x value. So what x value do we want to plug in? 3, 4, 5, 6? Let's just pick 3. Let's pick something simple to evaluate. So this is x is equal to 3, right? This spot right here. So let's see what happens when we plug in a 3 for x into our function. So here we're gonna get that's f of x is equal to 3 over, and then we're gonna plug in a 3 right here, right? 3 minus 2. So then this is gonna be equal to 3 over 3 minus 2 is 1. So then this is equal to 3, okay? So when we plug in a 3 for x, a 3 pops out for f of x. And remember, f of x and y are the same thing, right? So the coordinate point that we run into is 3, 3. We plugged in a 3 and it popped out a 3. So let's plot this point. So 3, 3 is right here, right? So that means that the rational function is going to come on this side and look something like that. All right, so now the last thing we have to do, I'll just make some room right there, is find the domain and the range. So remember, the domain is just your limits from side to side, right? Basically along the x-axis, and then the range is your limits that go up and down, right, along the y-axis. So first of all, the domain, you can see this is negative infinity in this direction, and then this is positive infinity, right, in that direction. So we have a valid function coming from negative infinity, right? Still valid, right? We have function, we have function, we have function. And then right here at x is equal to positive 2, we have a vertical asymptote, so we skip over that. And then here you can see that the function picks up again, right, along the x-axis. We're good, we're good, we're good, off into positive infinity. So here the domain would go from negative infinity to 2, right, positive 2. And then we're going to put a union symbol, right, because we're skipping over 2. And then we're going to say it goes from 2 to positive infinity. And notice I put parentheses around the 2 because we're not including 2, right? That's the specific number we're skipping over. Okay, and lastly, the range. Let's see, we're coming from negative infinity down here, right? And then this is positive infinity. So we're coming along here, we have function, right? We have function, right? The function's existing all along here. And then we skip over this horizontal asymptote, but then it picks up again right here, right? So we have function all the way to positive infinity. So for the range, it goes, we'll write it down here, from negative infinity to 0. And then we'll put a union symbol, and then again it picks up at 0, and then it goes off to positive infinity. All right, just a couple more here. So now we have f of x is equal to x over x squared minus x minus 2. All right, so the first thing we want to do is just find the x-intercept. So again, we can do that by setting the top equal to 0. So here we have a single x term, so we're going to say x is equal to 0. Now, there's nothing to solve here, so this is basically just our final answer. So we have an x-intercept at x is equal to 0. So along the x-axis right here at 0. So basically the origin. Now, to find the y-intercepts, we have to plug in a 0 for x and see what pops out for f of x, right, for y. So for this one, let's write it over here to the side. We're going to say that y is equal to, and then again, we're going to plug in a 0 for x. So we're going to get 0 over 0 squared minus 0 minus 2. So this is equal to 0 over, let's see, 0 squared is 0, 0 minus 0 is 0. 0 minus 2 is negative 2. And 0 divided by anything is simply just 0, right? So then here we have a single y-intercept at 0 as well. Okay, so we have a y-intercept at y is equal to 0. Okay, now let's find the asymptotes. So the horizontal asymptote, again, we just need to compare the biggest exponent on top to the bottom. So the biggest one on top is a 1, and the biggest one on the bottom is a 2. So here the bottom one is bigger than the top one, right? So this would be an example of this first case once again, where the bottom exponent is bigger than the top exponent. So our horizontal asymptote is right here, write it down here, at y is equal to 0. Now in order to find the vertical asymptotes, again, we just need to set the denominator equal to 0. So here we have x squared minus x minus 2. So you might notice we can actually factor this. Okay, so first of all, we're going to say x squared minus x minus 2 is equal to 0. And like I just said, we can factor this. And oftentimes, these trinomials you'll be able to factor. So here, let's split this up into two sets of parentheses. And again, they're going to be equal to 0, right? So x squared, we can break up into x times x. And then for these two numbers, we need two numbers that multiply to negative 2, but add up to negative 1. So in this case, it'd be a negative 2 and a positive 1. Okay, now in order to solve for our x terms, we simply have to set each set of parentheses, or each factor, equal to 0. So first of all, we're going to have x minus 2 is equal to 0, and we'll have x plus 1 is equal to 0. So here, solving for x, we can add 2 to both sides. So we get that x is equal to positive 2. And then on this side, solving for x, we'll subtract 1. So we get x is equal to negative 1. All right? So in this case, we have two vertical asymptotes. So we have a vertical asymptote at x is equal to, let's just say negative 1 first, and at positive 2. All right, great. Now let's graph this bad boy right here. So first of all, we have an x and y intercept at x is equal to 0 and y is equal to 0. So that's just the origin, right? So they both meet, or they both have an intercept at the exact same point right here at the origin. And actually, let me change this to yellow, right? We're plotting all our points in yellow. Keep it consistent. And then we have our horizontal asymptote at y is equal to 0. So this is our y-axis right here. This is 0. So that means we have a horizontal asymptote right here along the x-axis, right on top of the x-axis. And then we have two vertical asymptotes, right, at negative 1 and positive 2. So here's our x-axis. So we have a vertical asymptote at negative 1 and positive 2. So as you friggin' geniuses might notice now, we have more quadrants, right? So we have 1, 2, 3, 4, 5, and 6. And another thing that you friggin' geniuses might notice is that we have an intercept at the origin. And this intercept also happens to be right on top of this horizontal asymptote. Now, whenever you graph rational functions, you can cross the horizontal asymptote. Okay, and the reason for that is because a horizontal asymptote really just tells us what happens as we approach negative infinity and what happens as we approach positive infinity, okay? So a function can basically do whatever right here in the middle. It can also do anything, over here. But what the horizontal asymptote is really for is just to tell us, okay, what about when it's reaching negative infinity, okay? What is it approaching? And it's approaching the horizontal asymptote. So on this end, and on this end. So the horizontal asymptote, again, just tells us basically what's happening at the ends. But here, in the middle of the function, in the middle of the graph, it can cross that asymptote. Okay, and in this example, it's definitely going to cross the horizontal asymptote because we have an intercept right on top of it, going right through it. Now, whenever you have several vertical asymptotes, the space in between, the space in between is normally going to look something like a cubic function, like that, or like that, or it might even be a parabola, okay, like that, or like that. Now, in order to figure out what it looks like exactly, we simply have to plot a point to the left side. So we need to plot a point right here to the left side and a point somewhere over here to the right side, because then that way we can see, okay, do we have a point here and here? Oh, that must mean it's a parabola, right? Or do we have a point, over here and over here? Oh, okay, that means this must be something like a cubic function. Okay, so in any case, the points that we can test, let's try and keep them easy. Let's test this point right here, which is 0.5, right? That's x is equal to 0.5. And we'll also test this side right here. Let's test x is equal to positive 1. So again, we'll plug those into the function right here and see what pops out for f of x, or in other words, y. Okay, so first of all, let's try just a positive 1. So here we're going to say that y is equal to x over, but instead of x, right, we're going to plug in a positive 1, so we're going to say 1 over, and we're going to get 1 squared minus 1 minus 2. So here we'll get that y is equal to 1 over, let's see, 1 squared is 1, minus 1 minus 2. So 1 minus 1 is 0, and 0 minus 2 is negative 2. So here we get y is equal to 1 over negative 2. So negative 1/2, right? Or in other words, negative 0.5. Okay, so we plugged in a 1 into the function, right? A positive 1, and it popped out a negative 0.5. So we have a point at 1, negative 0.5, right? So that point right here, let's see, that's at 1, negative 0.5. Let's clean this up just to make it a little bit more legible. So 1, negative 0.5 is right there. Okay, so we get 2 points right here. Now we just need to find this third point at 0.5. And sorry, this should be negative 0.5, right? So let's plug in there negative 0.5. So here we're going to say y is equal to negative 0.5 over negative 0.5 squared minus negative 0.5 minus 2. So you can plug that into your calculator if you want, but I'm going to tell you that you should get 0.4. All right, so when we plug in negative 0.5, out popped a 0.4. Okay, so there's another coordinate point right there. So negative 0.5, positive 0.04 is about there. Okay, so it looks like this graph is going to be a cubic, and it's going to look something like that. Okay, one last thing I want to point out here is you can never touch or cross over a vertical asymptote. Those are completely different, okay? And the reason for that is because if you did, well, your function would be undefined at these points. And we can check that because let's just check this asymptote right here really quick. So this one is at x is equal to positive 2. So let's plug in a positive 2 into the function and see what happens. So here we would get f of x is equal to positive 2, right, over 2 squared minus 2 minus 2. So here we're going to get that this is equal to 2 over 2 squared is 4. And then 4 minus 2, well, that's the same thing as 4 minus 4, which is equal to 0, right? So this is equal to 2 over 0. And again, you can't divide by 0. And the same thing would happen if we plugged in this other vertical asymptote at x is equal, if we plugged in a negative 1 into the function, we would again get a 0 down here. So that's always going to happen at the vertical asymptotes. So we can never ever cross those vertical asymptotes. All right, so now that we got this middle section sorted, now we just need to figure out what's going on in these other quadrants. So in order to figure that out, again, we just need to plug in 2 points, one on this side and one on this side. So again, let's just try and keep this simple by plugging in some easy numbers. Let's just plug in this number right here, x is equal to negative 2. So here we're going to get that y is equal to negative 2 over negative 2 squared minus negative 2 minus 2. All right, so here we get that y is equal to negative 2 over, let's see, negative 2 squared is positive 4. And then again, here we're subtracting a negative, so that's the same thing as adding, plus 2 minus 2. So here this is equal to negative 2 over 4 plus 2 minus 2 is equal to simply 4. So this is equal to negative 1/2, or in other words, negative 0.5, right? We plugged in a negative 2 and out popped a negative 0.5. So our point is right here, all right? So then here we can say that we're gonna look something like that. All right, and then for our last point, we just need any x term over here on the right. So let's just pick this one right here. So what is that? 1, 2, 3. X is equal to 3. And again, you can work out the math if you want, but you should get 0.75. So the other point we get here is we plugged in a 3 for our x term and out popped 0.75. So let's plot that point right here. So 3, 0.75 is going to be about here. So that means this is the quadrant we're going to be in up here. All right, so we're going to look something like so. All right, and lastly, let's figure out, we're going to need maybe a little extra room now, the domain and the range. So the domain, as you can see, we're coming from negative infinity, so let's write that right here. So we're coming from negative infinity, and then the first vertical asymptote that we have to pass over is this one at negative 1. So we come from negative infinity, and then we hit negative 1, right? And then we're going to skip over negative 1, and then we pick up again at negative 1, and then here we come along, we have all this function in the middle, right? And then we hit this other one at positive 2. So it goes from negative 1 to positive 2. So then we'll put a union symbol, and then it picks up again after 2. And then our function just continues all the way to positive infinity like that, all right? And then for the range, you can see we're coming up from negative infinity, right? We have function, and then we hit this horizontal asymptote. We don't have to skip over it because we go right through it. So we still have function, and then we head off to positive infinity. So we have function all along this graph. It never breaks. So the range in this case would be from negative infinity to positive infinity. All right, here's the last example we're going to go over. So here's f of x is equal to x squared minus 9 over x squared minus 2x minus 3. So before trying to figure out the x and y intercepts, the first thing you want to do on a type of problem like this is see if you can factor this. And the reason for that is because there might be common factors that you might be able to cancel out. Okay, so for this first problem, let's say f of x is equal to, now on top you can see we have x squared minus 9. So that might look a little bit familiar. We can factor this because that, if we factor it, is a difference of 2 squares. So this would be the same thing as x plus 3 times x minus 3. Okay, now what about the denominator? We can also factor this, it looks like. So first of all, x squared is x times x, and then here we need two numbers that multiply to negative 3, but add up to negative 2. So in this case, that would be a negative 3 and a positive 1. Okay, so as you can see, we have the same factor on the bottom as we do the top. So whenever you have the same factor on the top and the bottom, there's actually a hole at this specific location. Okay, so here we're going to add an extra little line item. So we have a hole at x minus 3, right? X minus 3 is on the top and the bottom. So x minus 3. Okay, so I'm going to explain a little bit more what the hole is, but for now we can basically now just cancel these out, all right? So then we can rewrite our function f of x as on top, all we're left with is x plus 3, and on the bottom, all we're left with is x plus 1, okay? So now this is the function we're going to use to figure out all this information, the intercepts and the asymptotes. Okay, so it's almost like we're starting from scratch, from the beginning. So now we can start looking for the intercepts. So again, to do that, the x-intercepts, we just set the numerator equal to 0, right? So we're going to say x plus 3 is equal to 0. We'll subtract 3 from both sides, so we get that x is equal to negative 3. All right, so an x-intercept at x is equal to negative 3. And the y-intercept, again, we're just going to plug in a 0 for our x terms right here. So here we'll say that y is equal to 0 plus 3, right? 0 plus 3 over 0 plus 1, which is equal to 3 over 1, which is equal to 3. So we have a y-intercept at positive 3. Okay, now let's find the asymptotes. So the horizontal asymptote, again, we just have to compare the biggest exponents, and as you can see, they're the same exponent right here, right? They're both 1s. So since they're both equal to each other, that would be the second case. So that means our horizontal asymptote is going to be at the ratio of the two coefficients. And here you can see that the two coefficients are both 1s, right? So here we're going to say that y is equal to 1 over 1. So here we can see that it's at y is equal to 1, okay? And then for the vertical asymptote, again, we just need to set the denominator equal to 0. So x plus 1 is equal to 0. We'll subtract 1. So we get x is equal to negative 1, right? So we'll say x is equal to negative 1. Nice. All right. So we found everything that we need. So now let's plot this guy. So first of all, we have an x-intercept at negative 3. So here's our x-axis. Negative 3 is right there. We have a y-intercept at positive 3. So positive 3 right there. And then we have a horizontal asymptote at positive 1, right? So y-axis, horizontal asymptote. And then just a single vertical asymptote at negative 1. Okay, so as you can see, we already have our 4 quadrants, and we have an intercept in 2 of those quadrants, which is convenient because that means we know that this graph is going to look something like that, and then this graph is going to look something like that. Now, the last thing that we have to account for is this hole that we found. So remember, the factor was x minus 3. Now, in order to figure out where the hole is, you just set that factor equal to 0, right? So now, solving for x, we can just add 3 to both sides, plus 3, right? Those cancel out. So x is equal to positive 3. That's where the hole is. All right, so at x is equal to positive 3, right? This is our x-axis, positive 3 is right here. This is positive 3 right there. So if we move up to where we hit the function, there's a hole right here. Okay, so really, to make this a little bit clearer, we should delete that point right there and draw this hole, okay? So what this hole tells us is that at this specific x value, the function is undefined, okay? So the function is coming down along here, this yellow line, right? We have function, and then exactly at x is equal to 3, there's a gap in the function, and then it picks up again, and it just continues, okay? So these holes are literally just holes, they're just gaps in the function. All right, now lastly, let's find the domain and the range. All right, So the domain here, you can see we have function, right? We're coming along the x-axis from negative infinity, coming along. And then we have this vertical asymptote that we have to skip over, which is at -1. And then our function picks up again, right? So we have function, but we have this hole that we have to account for. So we have to skip over this point right here at +3, and then the function picks up again and just keeps going and going and going. Okay, so the domain goes from negative infinity, and then it hits -1, or it skips over -1, I should say, right? It skips over -1. Put a union symbol, and then it picks up again after -1, and then it keeps going all the way until we hit +3, right? +3, and then we skip over 3, right? And then it picks up again after 3, all the way towards +infinity. Okay, and lastly, for the range, you can see we're coming up from negative infinity, right? We have function, and then we skip over this horizontal asymptote, and then it picks up again, right? The function picks up again right here, so we just keep going all the way towards +infinity. So here we're going to say the range goes from negative infinity to, looks like +1. Then we skip over, right? Picks up after 1, and then off to +infinity and beyond. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.